Welcome to the 10th lesson in statistics for this CSEC mathematics series. In this lesson, we will learn how to extract information from various statistical charts that you are required to learn at this level. We will start with a pie chart. We have 5 categories, A, B, C, D, and E, with frequencies of 20, 30, 10, 25, and 15, adding up to 100. Since each slice is proportional to its frequency, category B, with 30, takes up 30% of the pie. To find the mode, we simply look at the highest frequency, in this case B. Because pie charts represent categorical data, things like the mean and median and quartiles don't really apply. Instead, we focus on patterns, spotting the largest slice to see the most common category, and comparing the others to find any big differences. In this case, category B stands out as the mode because it is the biggest slice. Now that we've examined the pie chart, let's move on to a bar chart, which presents the number of students participating in different sports. In this chart, the y-axis lists the sports football, basketball, volleyball, track, and netball, while the x-axis represents the number of students. Each bar's length corresponds to the number of students who play that sport. From the chart, we can see that football has the highest number of participants, making it the mode, while track has the lowest. The range, which is the difference between the highest and lowest frequencies, is 12 minus 5, and we get 7. To calculate the mean, we add the total number of students and divide by the number of sports. So 10 plus 5 plus 12 plus 8 plus 7 divided by 5 gives us 8.4. This means that on average, about 8 students participate in each sport. The median is found by arranging the frequencies in ascending order, 5, 7, 8, 10, 12. The middle value is 8, indicating that half of the sports have 8 or fewer students, while the other half have 8 or more. Looking at patterns and trends, we can observe that football is the most popular sport, while track has the fewest participants. Volleyball also has a relatively high number of participants, second only to football. This bar chart allows us to easily compare participation across sports, highlighting the most and least popular activities. Now that we've analyzed a bar chart, let's move on to a line graph, which shows the average daily temperatures over a week. The x-axis represents the days of the week, while the y-axis shows the temperature in degrees Celsius. Each point marks the recorded temperature for a specific day. The connecting points help us visualize how temperatures change over time. To extract statistical measures, we start with the mean temperature, which is found by adding all the temperatures and dividing by 7. The range, which tells us how much temperatures fluctuate, is calculated by subtracting the lowest temperature from the highest. To find the median, we arrange the temperatures in ascending order and identify the middle value. The mode, if applicable, is the temperature that appears most frequent. Looking at patterns and trends, we can see that temperatures remain low at the start of the week, rise sharply on Friday, peak on Saturday, and slightly decline on Sunday. The line graph makes it easy to observe these changes, allowing us to quickly identify the warmest and coolest days, as well as any sudden temperature shifts. Now let's analyze the histogram and frequency polygon, which display the grouped height data for 40 students. The x-axis represents class intervals, while the y-axis shows frequency. The histogram consists of touching bars since the data is continuous, and the frequency polygon connects midpoints of the bars to show trends. To extract statistical measures, we first calculate the mean by multiplying each class midpoint by its frequency, summing the results and dividing by 40. The modal class is 160 to 169 centimeters since it has the highest frequency of 15 students. The median falls in this same class as the 20th and 21st values lie there based on cumulative frequency. Quartiles, Q1 and Q3, can also be estimated within class intervals using interpolation. The interquartile range, IQR, is found by subtracting Q1 from Q3, and the range is approximately 50 centimeters, calculated using class boundaries. Looking at patterns and trends, the histogram peaks at 160 to 169 centimeters, showing the most common height range. The frequency polygon helps determine if the data is symmetrical or skewed, and comparing bar heights reveals how spread out the data is. These graphs make it easy to visualize height distribution. Using the same height data, we can plot an Ogive or cumulative frequency curve to analyze distribution trends. The x-axis represents the upper boundaries of the class intervals, while the y-axis shows cumulative frequency. Each point represents the total number of students with heights up to that class boundary, and connecting these points forms the Ogive. To extract key measures, we start with median, which is the 20th value out of 40 or 50% of the total. We find where the cumulative frequency reaches 20, trace it down to the x-axis, and estimate the median height. Similarly, the first quartile Q1 is at the 10th value, or 25% of the total, and the third quartile Q3 is at the 30th value, or 75% of the total. The interquartile range IQR is found by subtracting Q1 from Q3, and the semi-interquartile range SIQR is half of this value. Unlike histograms, an Ogive does not directly provide the mean or mode, as those are calculated from frequency distribution. Looking at patterns and trends, the Ogive shows how many students fall below a certain height. Steeper sections indicate higher concentrations, while flatter sections show fewer data points in that range. This makes it easy to estimate medians, quartiles, and overall data spread at a glance. Let's recap what we've covered across these diagrams. Pie charts and bar charts work best for categorical data, where the mode is the category with the highest frequency. While the mean and median are usually not applicable, these charts help visualize proportions. Line graphs are useful for tracking changes over time, allowing us to identify trends, range, and even compute the mean or median when treating data points as numeric values. Histograms and frequency polygons are ideal for grouped continuous data, making it possible to estimate the mean, identify the modal class, and observe the distribution shape for skewness. Ogives, or cumulative frequency curves, help us find the median quartiles and interquartile range, IQR, since they show cumulative frequencies over intervals. However, not every measure is directly visible in every chart, and we often refer back to the original data for precise calculations. Thank you for joining me in this lesson. Remember, you can find this content and additional resources on the website linked in the description. If you have any questions, feel free to ask, and I'll be happy to help. See you in the next lesson where we will discuss percentiles in data.